Hello and welcome back. Today we are going to dive into the topic of validity and reliability. When creating tests, making sure the test is testing what we think it is and making sure the results mean something. Otherwise, why take them? So let's go ahead and get started in talking about how we compare the test results. We need to make sure that the test is fair, and we need to make sure that the results have meaning. And by doing so, we can use standardization and norms. Standardization is like the standardized tests that we've probably seen or taken before. Things like the ACT or the SAT. Everybody is treated exactly the same, just like we do in an experiment is also true in a standardized test. So the same questions in the same conditions, interpreted the same way. When I, as a teacher, give these standardized tests, we literally read off of a script to make sure that every person in every classroom hears the exact same thing before, during, and after each test. When the test is done, we can then norm the test. We can take those statistics on the test, determining the average and the standard deviation, so we can find out where an individual falls compared to the rest of the population. Knowing if you're in the 98th percentile or the 84th percentile or the 50th percentile is what we can do with these standardized tests after a person has taken them. But we also need to make sure that these tests are valid and reliable. So let's go ahead and take a look at what that means. Reliability is asking whether or not the scores are consistent. So reliability is really looking at a correlation. A strong correlation of 0.8 or higher will tell us if that test is reliable, meaning the scores are repeatable or they are stable. So there are a few different ways that we can measure reliability. The first one is known as test-retest. We could have a person take the same test twice and their score should be consistent. Now this is not accounting for changing in between, restudying before taking it, but if a person were to merely take the exact same test in, say, 2 days in a row without doing any changing or prepping in between those two tests, their score should come out to be about the same. If we were to track them on a scatter plot, again, the correlation should be 0.8 or higher. If it's not, then there seems to be something wrong with the test. If we do this for a group and the correlation is not 0.8 or higher, it would indicate that there is something wrong with the test because the scores are not repeatable or stable. We can also use what's known as an alternate or parallel form, and this would be using two different forms, but they must be equivalent. In a class, this might be something like a test and a retake. If we were to give half of the class one version of the test and half of the class the other version, the averages for those two tests should be similar. If one seemed to be a lot harder or a lot easier than the other, then we aren't going to be able to determine if that test is actually reliable. And the final way to determine reliability is known as split half, where we actually split the test in half and we score them comparing the averages between the two halves. You could do this between the odds and the evens, or the first half or the last half of the test, as long as the test is not designed to get progressively harder as the questions progress. So this is how we measure for reliability. The other thing we need to test for is validity. And validity is asking, does the test measure and how well does it do so? Is the test measuring what it's supposed to? So one type of validity that we can look for is what's known as content-related validity. Is it representative of the domain to be measured? Meaning, is the test asking the right questions? If I were giving a test on, say, the learning and behaviorism unit, and there were development questions on that test, that would not be a content-related test, because that test is not representative of what you learned in that learning and behaviorism unit. Now, a test can look content valid, but not actually be content valid. And we call that face validity, meaning at face value, it looks like it's testing what it's supposed to, but it really is not. Some possible reasons why a test might have face validity but not actually be really content valid is because maybe the questions are on obscure content that wasn't actually covered in a course, or it could be that the questions were written really badly so that by just looking at it, you can say, yeah, these are all on a specific subject, but when someone takes it, they don't do as well on it. Could be because that face validity was there, but the content validity was not. Another type of validity we might look for is known as criterion related validity, also called predictive validity. And this is used when a test is meant to predict in some way a person's ability in a different area. So it could be a concurrent validation, so two different measures at the same time. That would be something like comparing your GPA right now and your SAT score, or comparing your grade in this class and your score on the AP exam, both of which happen within the same year. They should be predictive of each other, but they are predictive in a concurrent timeline. Predictive validity can also look into the future, comparing across time, looking at SAT scores and college graduation rates. We can see if there's a correlation between higher SAT scores and graduation rates, or SAT scores and college GPAs. What we're trying to see is if the information we have now will predict future success in another area. If it doesn't, it might not tell us what we think it's trying to tell us, and it might not actually be valid. The final type of validity that we need to know is known as construct-related validity. And this one's a little bit trickier because we're not predicting anything, but this is used instead to confirm. And usually it's used when confirming a theory. We see this in the field of psychology. If a person is setting up a test or a protocol, if they're creating, say, a new test and they want to see if it confirms a theory that they have, we would use construct-related validity. An example of this would be to make a test for Maslow's hierarchy of needs to see if a person has reached self-actualization. We have a theory about what self-actualization is. Now we're trying to create a test that is going to confirm that. So with Maslow's hierarchy, if you remember, we can't be self-actualized if the first 4 steps haven't been fulfilled. So if a person takes the test and it says they're self-actualized, but they have no home, is the test accurate? Or is Maslow's theory wrong? This is the problem with construct-related validity. You might have to go back and change the test, but you might have to go back and reevaluate the theory as well. So maybe I want to create a test on happiness. So first I have a person rank themselves, how happy do you think you are, and then take a test. We want to see if their score on the test is the same as their own self-perceived happiness. If it's not, then maybe either I'm defining happiness wrong, or my test is not a good measure of telling whether or not a person is happy or not. So construct-related validity is really something that we see a lot in the field of psychology if you're trying to create and test a theory. So these are the 3 types of validity, and we have 3 types of reliability. And these help us to make sure that tests are actually testing what they're supposed to, and that the scores actually mean something. Of course, we still have to consider the bias that exists in many types of tests, but this helps us to at least make sure that there is no blatant problems with the test that we are giving. We're going to go ahead and stop there, but hopefully gives you a little bit better understanding of how psychologists assess intelligence and how they try to make sure these tests are as accurate as possible. So thank you so much for watching, and as always, remember, be kind to your mind.